These are some names. Omega t plus delta is an angle which we call as phase. Delta is an angle which we call as phase constant. It tells us the t equal to 0 status when the stopwatch was pressed. Omega has reciprocal relationship with t, just like frequency has, but omega t is an angle. Omega t is an angle. So omega is called angular frequency. Now we will do some applications, and later on when we talk about the visualization with a circular motion, then you can appreciate these angles better. Omega t plus delta as an angle, delta as an angle. At this point we will take more problems. Some particle having mass 10 grams is performing SHM. This is the equation. This 2 is in centimeters. This is SI unit. Pi by 6 is in radians. Amplitude, time period, constant K. How much? That's one question. Then at t equal to 0, these three. A is clearly 2 centimeters. Then omega is 100. If omega is 100, then t would be 2 pi by 100. Now how do we find K? T equal to 2 pi root m by K. T we know, m we know, so K should be no problem. And the answers for these are If you have any question in any of these three, then let me know, or we talk about this part. Talking about these, you just have to put t equal to 0 to find x. For velocity, you would need to differentiate. And when you differentiate, and now put t equal to 0. You will get b with time. These derivatives take care of direction also. So you will be able to tell vector v. Right side, it's going to the right side, or if it's going to the left side, all that. And then we differentiate it once more. Well, for acceleration you have two choices. You differentiate this, that's one choice. Second one is you use vector A equal to minus omega square vector x. X you already know from this part. So that's another way to know acceleration. That is with direction. And regarding the answers for these, I have written down the magnitudes. Now as far as directions are concerned, I think this should be positive. Then velocity, that should also be positive. That means right side. Displacement is to the right side, velocity, yes, is also to the right side, and acceleration, that has to be to the left side then. Any questions? If you have, let me know. So that 5 is in centimeter, that means x is in centimeter, t is in seconds, obviously pi by 3 is in radians. Suppose we are watching the particle from t equal to 0. The stopwatch was pressed at t equal to 0. First I am giving you the answers and then we can discuss whatever you ask for. Okay, these are the answers. Now, if you would like first part to be discussed, raise your hand. Okay, so looks like no problem with part A. Part B. If you would like part B, okay, fine. Zero acceleration. Now, if you put t equal to 0, sine of pi by 3 is positive. You can see right now, I mean, when the stopwatch is pressed, particle is somewhere here, and if you differentiate it, you will get cos pi by 3 positive. Velocity is also positive at t equal to 0. So particle is going to the right side when stopwatch is pressed. First have zero acceleration. Okay, it will go like this. Come to rest, it will turn, reach here. That's where it will have zero acceleration also. Okay, B and C should have the same answer. Zero acceleration and maximum speed. And that will happen at x equal to 0. So you just need to put x equal to 0 here. That's where it will happen. X equal to 0 if you put, then you get sine of 20t plus pi by 3 equal to 0. Which means that 20t plus pi by 3 is n pi. N pi t is a positive number. I can't put n equal to 0. I want smallest t. I think n equal to 1 is what I would need to put to get minimum positive t. If I put n equal to 1, I get 20t equal to pi minus pi by 3 which is 2 pi by 3. That means t is pi by 30. If you have any questions, B or C parts, let me know. There's a private message about n equal to 1. Okay, I will try to further explain that. You are solving this equation 20t plus pi by 3 equal to n pi. You want minimum value of t. Now tell me what choices do you have? N is an integer. From trigonometric equations, n is integer. So what choices do you have? If you put n equal to negative, you will never get t positive. If you put n equal to 0, even then you get t equal to negative. You can put n equal to 1, 2, 3, 4, 100, 1000. But minimum t will happen when n is 1. Any other questions? Let me know. Try this. You can take the easiest equation. Just take delta equal to 0. Delta tells about the initial status only. A by 2 A. You have to find T2 minus T1. First, I will give you the answer that I have. Then I can discuss if required. And the answer I have is T by 6. And now, if you would like me to discuss it further, raise your hand. Okay. Omega T1 is half. Sin omega T1 is half. So omega T1 is pi by 6. Let me know if you have any questions. The only problem is delta, the initial status, that is. And that initial status has to be found from this information. And the answer for delta that I have is pi by 6. If you would like this part to be discussed, raise your hand. Okay. Now, magnitude of acceleration. The answer for that I have is (11 centimeter per second square). If you would like this part to be discussed, then raise your hand. we have called K a general constant. In case of spring mass system, it is the spring constant. So, this is the formula for T for a system like this, where K is the spring constant. Now think about this question. Slight modification. We are talking about ideal springs. What would be the period of oscillation now when two springs are connected? That's good. And the explanation is this. When you pull it a bit and you leave it, it goes right, left, right, left. Imagine it is X on the right side. This spring is also pulled by X. So how much force will it apply? K1X. When this is here, spring this is also pulled by X. So how much force will it apply? K2X. So the net restoring force towards center means this, mean position. Net restoring force towards center will be this. And if you are wondering how did we get this result, imagine it to be X on the right side. Then this spring is also pulled by X. So it is having force Kx on the left side. I am not using vector notation. If I use vector notation, then vector X is on the right side, vector F is on the left side, so there will be minus here. That's how you identify SHM, isn't it? So this K is same as the K of SHM. And once you get F equal to minus Kx, that's the K you have to put here. So here it is like this. K1 plus K2 is just like another K. And direction wise also, if you see, the X vector is on the right, force vector is on the left. So it is satisfying the condition for SHM. So that's the K we want. So T is 2 pi root m by K, where K is K1 plus K2. Any questions? Let me know. What do you think about this? What would be the time period? So you are getting same as before. In that answer, root is missing, last one. Okay, RT. That typing is not very clear. Use brackets properly. Now the answer is correct. Imagine you have pulled it to the right side and you have released it. So right left is going. Imagine it is X on the right side. X is some instantaneous location. It doesn't have to be the amplitude. Now this spring is compressed, so it will apply force in this direction, K2X. This spring is elongated, so it will also apply force in this direction. So the total force towards the mean position is this. If I use vector notation, there will be minus sign. This is a requirement for SHM. So it's fulfilled. Once the requirement is fulfilled, it will be SHM. And the period will be any questions? Let me know. Here the question is, will it be SHM? And if yes, what is the time period of oscillation? Will it be SHM? If yes, what is the time period of oscillation? The answer to the first question, that will it be SHM, is yes, it will be SHM. So you have to tell me what is the time period. That is your assignment question. We stop now.